random walk. Introduction. This video simulates a Bernoulli random walk, that is, a binomial random walk sampled at its realization frequency 1/tau. The time axis is clocked at regular intervals tau. At each of these moments, walking is done at constant velocity in one direction or the other according to the constant probability p. The standard deviation of velocity is measured over the entire data series at each interval tau. The point S, defined by the average velocity and its standard deviation, is on a half circle of radius equal to the instantaneous velocity. We therefore find the configuration presented in the video Alain Connes time, a hyperbolic, Euclidean, stochastic sketch. In the calculation presented here, tau equals 1 and c equals 1. We generate 500 random values of velocity -1 or +1 depending on the probability p, that we add from location 0 to represent the displacement. The average velocity is calculated by the mean of all instantaneous velocities. The standard deviation involves the 500 steps. The displacement is represented vertically by the purple point. It is adjusted by the scale motion setting to be able to overlap the semicircle of velocity. The half circle alternates the occurrence of instantaneous velocity -1, red point, or +1, green point. The blue point S has for ordinate the average velocity calculated over the 500 steps, and on the abscissa the standard deviation of velocity. The gray point is the theoretical locus corresponding to the probability p, that is, 2p-1, on the ordinate and 2 square root of p, 1 minus p, on the abscissa. P equals 0.7. First pass in slow motion and large scale for displacement. We launch the visualization of the displacement calculated in the spreadsheet. The scale for motion is 100. That means that the minimum step is 100 times smaller than the unit of the graph. The units for the half circle of velocity are 1. Synchronously with the instantaneous motion of the purple point, the corresponding occurrences of the instantaneous velocities are seen flashing. There are more green occurrences and the displacement is positive with approximate velocity 0.4 and standard deviation 0.9. P equals 0.7. Second pass faster. The scale for motion is set at 400 to follow the entire motion. At the end of the first visualization, at the end of the path, one can change the 500 random values all at once and see the dispersion in average velocity and standard deviation. P equals 0.5. The displacement is restricted around the value 0. The scale for motion is set to 50 to focus on the entire motion. P equals 0.1. The displacement is negative. The scale for motion is set to 500. p equals 0. The displacement is uniform and the standard deviation is 0. The scale for motion is set to 600.